right. So we are starting 2.6 today. Your 2.6 homework is going to be due on Friday. .6 and 2.7 are about inequalities. So up until this point in chapter 2, we've been talking about equations, talked about all different types of equations. We're going to keep along that same vein as far as solving goes, but we're going to switch from solving equality to solving inequality. So I want to talk about interval notation for just a minute. You guys should have been exposed to this already. When we use interval notation, we use parentheses and brackets. It can end up looking almost like an ordered pair, but it's describing a solution set. So if I have an inequality where x is in between a and b, if I was graphing that on a number line, if a was here and b was here, if you just have a less than, what kind of a dot would you use there? Open or closed dot? You use an open dot on that, right? We only fill in the dots when it has the or equal to on it. And then my solutions are everything that's in between. The way we write that using intervals, if it would get an open dot on a number line, we use a parenthesis for it. We put the smallest value that would satisfy first, and then we put a comma, and then we put the largest value. When you write using interval notation, you do not need to include the variable there at all. What that interval is telling me is that every number in between a and b would work for x, except for actually using a or actually using b, because we didn't have the filled in dots there. Yes?
How come our quizzes are timed?
So that we still have teaching time afterwards. That's the biggest reason for it. Your tests you'll have the full class period for. When we have the or equal to in our inequalities, how does that change the way you would graph it on a number line? You'd fill in the dots. That would be the only difference on my graph when I'm looking at it. I'm still talking about the space in between. The way that changes my notation is instead of a parenthesis, I have a square bracket. That square bracket means that it's inclusive of those values. It means I can include those as solutions. If it has a parenthesis, it's exclusive. It's everything in between, but not those actual numbers. So far, so good? Okay. I'm going to scoot my pictures up just a little bit. What would the number line look like for x is less than or equal to a? Yes. If my a is right here, it's going to be going to the left. Filled in because of the or equal to, and shaded this way. So if my interval notation always needs to be telling smallest thing first and then biggest, but it keeps going on forever and ever and ever to the left, infinity. In the negative direction, so I'm going to put a negative in front of it. Even though technically infinity goes on forever in both directions, this way I know I'm talking about the negative direction. So I have negative infinity. I use a parenthesis with that because can you ever actually get to infinity?
No.
No. So we use a parenthesis there. All the way up to a, that's the biggest thing it could be. And I want to bracket there because it includes that value. How would that be different than the one below it?
It wouldn't be a parentheses.
Yep. It's going to look almost exactly the same except parentheses on both sides. What do you think about the two that are below that? Mm-hmm. Bracket B, because it includes that value, comma, infinity, and then a parenthesis. If it makes you feel better to put a plus with the infinity so that you know you're talking about the positive direction, that's fine, but you don't have to. A lot of times in calculus, they will put a plus there just so that they're really clear about which direction they're talking about.
Wouldn't you put B, infinity first since it's bigger?
So when we're doing our interval notation, that's a great question. Interval notation always lists the smallest thing first and then the biggest thing.
Oh, the smallest, okay.
Yep, so like here, because of the way this is written, A would come first and then B, and so in my interval, it's the smaller number and then the bigger number. Always, always, always. Good questions. So what about the one below this? What would it look like? Yep, it's going to have a parenthesis instead of a square bracket because it does not include that value for B, and then on to infinity. All right, so next to last, this looks a lot like those top two, right? What makes this one different than the top two? Yeah, one of them has just the less than, so that's going to get a parenthesis. The other side has the or equal to with it, and so this side is going to get a square bracket. So I'm going to have A and then B, but on the B side we have a bracket. Down at the bottom, what will this one look like? Negative infinity to positive infinity. Does anybody know what that means, like in words? That is all real numbers. All right, there's one more that I want to throw on here. I'm going to draw the picture, and we're going to write both the inequality notation and the interval notation.
Do we draw these two?
Yep, go ahead and draw this in your notes.
Okay.
All right. All right. If this is what you saw graphed on a number line, how would you express that with inequalities? I heard greater than. Greater than what? Everything? Are there any values that wouldn't work here?
Yeah,
Whatever's in between A and B. So to write this with inequalities, I would say that X is less than or equal to A, right? Or what? Yes.
or greater than B.
X is greater than B. So that's how I would write this with inequalities. When we talk about our interval notation, we're going to have three pieces, just like we do with the inequalities for something like this when it's going opposite directions. So A is less than or equal to A. If I'm just looking, or sorry, X is less than or equal to A. How would you write just that idea using the interval notation? Negative infinity to A with the square bracket around it. The or, we use a union symbol. It means together with. And then how would you write X is greater than B? and then infinity, and another parenthesis. Perfect. That one will become important later, but I did want to make sure that we had it written down somewhere so that we know if we've got it shaded in different directions, how do you even go about writing something like that? All right. How are you guys feeling about just our notation that we're going to use? Pretty good? Okay. I will tell you right now that the first part of the homework, probably the first 5 or 6 problems, are just I give you an inequality, you write the interval. Or I give you an interval, and you write the inequality. So just practicing this idea is the first several homework problems. All right, let's solve some inequalities. And we're going to give our answers back using interval notation. So what would I need to do on part A to solve this guy? Subtract 8 from both sides. So I have 3x is less than -1. Do I need to flip my sign?
No.
When do I need to flip the sign? When we divide or multiply by a negative. So in this case, if the 3 had been a negative, then I would flip it. Since I'm not dividing by something that's negative, I don't need to flip my sign. So x is less than -1/3. There's my inequality answer. I want to write it as an interval, though. What would that look like?
Negative infinity.
Negative infinity
Parentheses.
with a parenthesis around it.
1/3, parentheses,
-1/3 and a parenthesis. For all the actual problems that you do on Canvas or in your homework that you'll put your answers in on Canvas, you're going to enter them as intervals like this. Don't put any spaces in between things. Like when you type it in, just run it all together. And for the infinity, if you need to put that into Canvas, which you probably will on some of these problems, you're going to just type INF instead of trying to do the symbol, okay? So if it's negative infinity, you would do negative and then INF, okay? Let's look at B. Do you guys feel like working with fractions? What could I do so that I don't have to work with fractions anymore? Multiply. What can I multiply by? I can multiply everybody by 5. I have to do that to every single piece. So that's going to cancel out my denominator here. Will that get rid of all of my denominators?
Not the 3.
Not the 3. So if I multiply everybody now through by 3, can I get rid of that one too?
Yeah.
So I'm going to multiply everybody by 3. That way, I don't have to work with fractions anymore. All right, so this first one, I would have 3x plus 4 times 5, 20 times 3, I get 60 greater than or equal to 5x minus, what would that be? 35 times 3, 105. All right. What should we do after that? Yep. Combine our like terms. I heard subtract 3x from both sides. That's perfectly okay. All right, so I would have 60 is greater than or equal to 2x minus 105.
Could you still subtract 3x from both sides if there wasn't a greater than or equal? If it was just greater than, can you still do the subtraction?
Uh-huh. Yep, absolutely. I'm going to add 105 to both sides. So I have 165 is greater than or equal to 2x. Divide both sides by 2. You can write that as the decimal, or you can just leave it as the fraction. Especially on a test or a quiz, I wouldn't bother with changing this. I would just leave it as a fraction here. So 165 over 2, or you could write that as 82.5. is greater than or equal to x. Most of the time when we write inequalities, do we write them like that? Most of the time our variable goes on which side? Most of the time the variable's on the left side. It really doesn't matter, but when I go to write my interval, it would be really helpful if I had the x on the left so that I would know which way I'm supposed to shade, right? What would this look like if I turned it around?
X is less than.
Yes, x is less than or equal to 165 over 2. That's probably how I would write it so that I can see my interval better. What would my interval look like now? Negative infinity with a parenthesis. 165 over 2 with a bracket. Love it. All right. Talk to me about part C.
You only do what you do in the middle to both sides.
Yes, whatever we do in the middle, we got to do to both sides. I know my daughter, when she learned how to do this, they had them do double fences. Yeah, when she learned how to solve equations, they had them draw a fence where the equal sign was. If you guys never learned that, that's fine. I think it's one of those supports that they put in when people are very beginning to learn this stuff. So we're going to add 2 to every side here. So I would have 5 is greater than 4x is greater than negative 3. Divide everybody by 4. Do I need to switch anything? Nope. So I have 5/4 is greater than x is greater than negative 3/4. Should I leave it written like that so that I can do my interval? Think about the interval. What always comes first in an interval? Smaller number. Which one of those is smaller? Negative 3/4 is going to go on the left side of my interval. So I'm going to rewrite this the other way so that that makes it easier for me to write my interval. And when I turn it around, those inequalities need to make sense with it as well. So what will this final answer in interval notation look like? Parentheses, negative 3/4, comma, 5/4, and a parenthesis. Beautiful. Why don't we stop there for today? Sound good? All right. Go ahead. Remember, your 2-5 homework is due by midnight tonight. So if you have not finished up 2-5, please finish that and turn it in. The 2-6 homework, which is due on Friday, it has more problems in it than some of the past ones that we've done. But like I said, the first 5 or 6 are all just, here's interval, write it as an inequality. Or here's an inequality, write it as an interval. So you can probably get the first 6 or so knocked out.